Our home, the Earth, is estimated to be 4.54 billion years old, give or take about 50 million years. Today we are accustomed to living among diverse communities of animals. However, this has not always been the case. For a while, the Earth was not a very welcoming place for living organisms, as it was devoid of oxygen and full of hot toxic gases. The earliest life forms we know of were microscopic organisms called microbes that existed about 3.7 billion years ago. We have evidence of their existence from microbial fossils in rocks dating back to that time. At least 2.4 billion years ago, organisms called cyanobacteria evolved in the ocean and became the catalyst for a remarkable transformation. They became the first photosynthesizers, using water, the sun's energy and carbon dioxide that was spewed from volcanoes to create oxygen. This set the Great Oxidation Event in motion, which would occur millions of years later, during the Paleoproterozoic era. The Great Oxidation Event was a time interval when the Earth's atmosphere and the shallow ocean first experienced the rise in the amount of oxygen. After the initial surge of oxygen, it stabilized at lower levels, and so the ocean still wasn't ready to support most life forms that require ample oxygen. Fast forward to 600 million years ago, oxygen levels in the oceans and atmosphere had increased dramatically. The oxygen in the atmosphere reached about 1/5 of today's level, which is 21%. It is believed that this increase resulted in the burst of sea life known as the Cambrian explosion 530 to 509 million years ago. This event was characterized by the evolution of hard body parts such as calcium carbonate shells. Many species independently evolved hard parts about the same time. The reason for this is still debated, with a leading theory being that the amount of oxygen finally reached levels that allowed larger and more complex animals to exist. Following the Cambrian explosion, the biosphere continued to expand relatively rapidly, until it didn't. About 440 million years ago, at the end of the Ordovician period, mass glaciation took place in the African and South American portions of the supercontinent Gondwana. This led to a substantial drop in sea levels and a major disruption in the food chain. This occurred in a period when the living organisms had not yet ventured onto the land and most of life was in the ocean. As a result, 85% of all species became extinct. This was the first major mass extinction event, but certainly not the last. Throughout the history of the Earth, there have been 5 major mass extinctions, and more than 99% of all the species that have ever lived have become extinct. The second mass extinction, the Devonian, was actually a series of mass extinction events that happened about 365 million years ago and eliminated 75% of the Earth's species. The causes of these extinctions are not yet clear. The leading hypotheses suggest a combination of several reasons, including ocean anoxia, a reduction of oxygen levels possibly due to rapid global cooling, and the impact of a comet. However, out of the 5 major extinctions, the Devonian ranks lowest in severity. On the other hand, the next extinction in line, the Permian-Triassic, is also known as the Great Dying, and with good reason. 252 million years ago, life on Earth almost ended, as up to 96% of all the species became extinct. The primary cause of this extinction is believed to be massive volcanic activity in an area called the Siberian Traps. The eruptions elevated the air and sea temperatures and released enormous amounts of carbon dioxide, making the water acidic and uninhabitable for marine organisms. What is more, clouds of volcanic ash formed in the atmosphere, hindering the use of sunlight and inhibiting photosynthesis, leading to oceanic anoxia. The fourth one, called the Triassic-Jurassic extinction, was not as devastating as the Great Dying, but it is thought as the key moment that allowed dinosaurs to rule the Earth. Many scientists believe that this event was caused by climate change due to a major increase in CO2. Studies show that the rifting of the supercontinent Pangaea may have released up to 100,000 gigatons of CO2, resulting in an increase of average air temperature by as much as 10 to 15 degrees Celsius and acidifying the oceans. 75% of all species died out, and this opened many positions in the ecosystem which were quickly filled by dinosaurs. They roamed the Earth for millions of years, but then came their turn. The Cretaceous-Paleogene extinction event came suddenly approximately 66 million years ago. 3/4 of all plant and animal species and most tetrapods weighing more than 25 kilograms became extinct. There isn't much room for speculation as for the cause of this event. As originally proposed in 1980, it is generally accepted that this extinction was caused by the impact of an enormous asteroid 10 to 15 kilometers wide. This destroyed the environment as the impact ejected a substantial amount of dust, ash and other debris into the atmosphere, blocking the radiation from the sun. As a result, global temperatures decreased drastically and photosynthesis was halted. This extinction provided many evolutionary opportunities. Many groups, especially mammals, diversified during this era, evolving new forms such as primates. This paved the road for human evolution. Physical and genetic similarities show that the modern human, the Homo sapiens, is very closely related to another group of primates, the apes. Unfortunately, the evolution of humans has not had a positive outcome for the environment. Ecologically, humanity has been noted as an unprecedented global superpredator that preys upon other apex predators and has worldwide effects on food webs. The 5 previous mass extinctions were caused by natural phenomena, but experts now believe that we are in the middle of a 6th one due to human activity. Currently, the species extinction rate is estimated to be between 100 and 1000 times higher than the background extinction rate, which is the standard rate of extinction in Earth before human intervention played a major role in extinctions. Just in the past 500 years, more than 875 animal and plant species have gone extinct. But this is only the beginning. Various species are predicted to become extinct in the near future, among them the rhinos, non-human primates and giraffes. Recent assessments have discovered that roughly 41% of amphibians, 25% of mammals, 21% of reptiles and 14% of birds are threatened with extinction, which could disrupt ecosystems on a global scale and have a catastrophic outcome. But what is actually driving these losses? First and foremost, the perpetual use of land and water has become the dominant problem, as 30% of all land that sustains biodiversity has been converted for food production. What is more, agriculture is responsible for 80% of global deforestation and accounts for 70% of the planet's freshwater use, harming the species that inhabit those places by ruining their habitats. To make things worse, human activity, such as transportation and electricity production, contributes to the rise of greenhouse gases, which in turn are causing an increase in atmospheric temperatures, ravaging the Earth. The climate crisis is expected to annihilate the ecosystem in the 21st century. Rising levels of carbon dioxide are resulting in an influx of this gas into the ocean, making it inhospitable for many marine species. Furthermore, the overexploitation of many species has affected their populations very negatively. The extinction of the dodo bird is one of the most famous examples of this. The dodo was a flightless bird that lived in the island of Mauritius in the Indian Ocean. They were discovered by sailors around 1507, but were unfortunately driven to extinction in less than 200 years after that. Nowadays, trophy hunters are playing a significant role in the decline of giraffes, which is referred to as a silent extinction. Their number has plummeted dramatically in the past 30 years, by up to 40%. The increase in mass killings due to poaching, in addition to loss of habitat, is very threatening for African elephant populations. In 1979, their population stood at 1.7 million. At present, there are fewer than 400,000 remaining. They could become extinct by 2035 if poaching rates continue. In the oceans, overfishing has had a massive effect on marine organism populations. A 2020 study published in Science Advances found that around 18% of marine megafauna, including iconic species such as the great white shark, are at risk of extinction from human activity over the next century. In a worst-case scenario, 40% of all sharks and rays could go extinct over the same time period. If humanity stays idle, we will continue to lose many species at an alarming rate. Species do not exist in isolation, they are interconnected. When one goes extinct, it damages the whole ecosystem and increases the risk of extinction for other species. However, we have not yet reached the point of no return. Urgent action needs to be taken by all humanity if we are to limit human impact in the physical environment and preserve biodiversity for future generations.